So your last question. All right. So just about we've talked about that. So let's talk about electrical safety.
Okay.
All right. So tell me, what kind of what's the main supply in the UK?
So in the UK, our main supply is alternating current at a root mean squared of 240 volts. So this has a maximum voltage of about 340 volts.
Why do we use alternating current, not direct current?
So we use alternating current because it allows large amounts of energy to be transferred across large distances without too much loss of energy. So it's efficient, cost effective, and allows sort of a reliable power source. However, it does then cause safety implications.
What's the function of the earth wire?
So the earth wire is designed as a route for which the electricity to run back to earth if there is a breakage in the circuit. However, there are some situations where the patient or staff member can themselves become the earth, which can cause safety issues.
Okay. What's the color of the earth wire?
Sorry, which colour?
Yeah.
So the earth wire is blue. No. Yellow and green, I think.
Okay. Tell me, what if somebody gets electrocuted? What are the factors that will determine the severity of that shock?
So the severity of the shock depends on lots of things. So the actual voltage supplied, the current density, the time that the current is supplied for, the location. So the location of the entry and the exit point. So whether this is a current that's going across the whole body or just in one part of the skin, out another part of the skin. And specifically with sight, if it's anywhere near the myocardium, then that can cause much worse consequences of electric shock.
Any other factors?
So any impedance. So for example, wet skin has low impedance, dry skin will have higher impedance.
What about the type of current?
Oh, sorry, yeah. So the type of current, so alternating current is more dangerous than direct current when applied to a patient.
Is there any reason why?
Is it just to do with the current density that is supplied to the patient?
I think the current density will be the same for the two.
Okay.
It depends on the current and the area that's in contact. So, well, anyhow, let's move on. Yeah. I was going to say, how do you classify electrical safety equipment?
So electrical safety equipment is classified into class 1, class 2, and class 3 devices based around their safety. And these are further subclassified as to whether they are with letters as well. So for example, B, C, and F. So class 1 devices must have a earth wire. They are the minimum safety standard, and often things like electric heaters, for example, used in the home. So the idea of this is that if there is any leakage of current, that flows down the earth wire rather than through the patient or through the person. Class 2 have a protective casing around them, so that no live parts should be in contact with the outer casing, meaning that the risk of electricity is low from that point of view. And class 3 electrical safety devices are should be internally powered. They shouldn't be connected to the mains at all. So they're the safest of the three, and they don't require an earth wire. The presence of an F in the class indicates that it's a free or a floating circuit, so that it's its own circuit and it's not connected to the mains. The presence of B means it's safe for application onto the patient's body, and the patient of C indicates it's safe for application around the heart.
In a CF equipment, what's the maximum allowable leakage current?
So it's less than 0.05 milliamps as leakage current.
All right. Oh, we're done.